Hello my AP Statistics students, Mr. Louie here, and in this video I wanted to cover the 2015 AP Statistics Free Response question. Like I say all the time, every single year they are going to have some four-step process problem on there. And half of the battle is making sure that you read the problem and know which of the several inference methods you learned about that you're going to use for it. So let's kind of jump right into this one. So it says over here, a researcher conducted a medical study to investigate whether taking a low-dose aspirin reduces the chance of developing colon cancer. As part of the study, 1,000 adult volunteers were randomly assigned to one of two groups. Half of the volunteers were assigned to the experimental group that took a low-dose aspirin each day, and the other half were assigned to the control group that took a placebo each day. At the end of the 6 years, 15 of the people who took the low-dose aspirin had developed colon cancer, and 26 of the people who took the placebo had developed colon cancer. At the significance level alpha equals 0.05, do the data provide convincing statistical evidence that taking a low-dose aspirin each day would reduce the chance of developing colon cancer among all people similar to the volunteers? So, a few things we got to look out for here. First of all, you notice that we have two different groups here. They even say it right here. We have two different groups. All right, this is obviously an experimental design. And so the other question, so we're probably going to be using an inference method that deals with two populations, either two proportions or two means. So now the next thing you got to ask yourself, is this a categorical situation or a quantitative situation? And really just based off of this, they either have colon cancer or they don't, right? So really you can create a proportion of people who have colon cancer. So right there, I already know I have two populations I'm dealing with, right? One population being the people who, use the placebo or who wouldn't use the low-dose aspirin pill. And then the other population being those who did use the aspirin pill. So you really got to make sure that you read the problem and know exactly what inference method you're going to do. Once you do that, the four-step process is pretty straightforward. So we know we have two populations and we are dealing with proportions. All right, so right there, I just know what I'm going to do. And the other thing that you know that you're going to do here is it says, do the data provide convincing evidence? Okay, statistical evidence, right? This is going to go ahead and make it clear that what we're going to be doing here is a hypothesis test, not a confidence interval. That's the other thing you got to look for. So we're doing a hypothesis test for two populations, and we're dealing with proportions. So, being that we're doing a hypothesis test, let me go ahead and set up my null and alternative hypothesis. The null hypothesis is always pretty simple. It's usually saying that there is no difference between the two populations. So we could just go ahead and say that let me just do P asp is equal to P plus, like asp for aspirin and plus for placebo. Now, the tricky part about this question is knowing, how am I going to compare the aspirin versus the placebo in this problem? So I look at this and say, do the data provide evidence that taking a low-dose aspirin each day would reduce the chance of developing colon cancer? So they want to know, will the proportion of those who took aspirin have a lower, right? Is this going to be lower, or the proportion of people who develop colon cancer here, is it going to be lower than the proportion of people who took the placebo? All right. So that's how you set up your hypothesis, and that's always the first step in making sure that we get this right. So now after we go ahead and set up our hypothesis, we're going to go and define what these mean. Because to someone who's foreign to this problem or foreign to your study, they don't even know what that even means. So we got to make sure we define that for them. Where P aspirin is the true proportion. Make sure you use that language. It's the true, and then whatever quantity you're measuring, proportion of adults, and let's just say in the study that develop colon cancer. Let's say that develop colon cancer taking aspirin. And P placebo. See, I always struggle, and I can't even spell. I always struggle with writing these concisely, but I always get the right information, so that's good. If you have a more concise way of writing this, then you're good. Proportion of adults in the study that developed colon cancer taking the placebo. All right. So that's one of the two of the three check marks taken care of. Set up our hypotheses, define our variables, and then we also got to tell what significance level we're going to use. They already told us which one to use. So we're going to use alpha equals 0.05. All right. Perfect. So that takes care of the first step of our four-step process. We got to define our hypotheses. Define our hypotheses, set up our hypotheses, and tell them what alpha level we're going to do. The next thing, and this is usually under the plan step, I'm just going to jump straight into it. We got to say what inference method we are going to use. So I just like to explicitly write out inference method and say that this is going to be a 2 proportion. You could also say 2 sample, that works just as well. A 2 proportion Z, and it's a hypothesis test, so do not put an interval there, please. Z test, and I'm just going to say 4 P aspirin minus, because we're pretty much trying to figure out the difference between the two, minus P placebo. All right. And then we got to get into our conditions. The first condition is that this is it's either a random sample or that the assignments were randomly assigned. Not the assignments, the treatments were randomly assigned. So that's pretty clear in there that they say that half the volunteers were assigned to the experimental group that took low-dose aspirin each day, and the other half were assigned to the group that took a placebo. So really, you just have to acknowledge it and say that the treatments were randomly assigned. And something that a lot of kids get wrong on these AP exams is whenever they see, sometimes they'll put random and then a check mark. That is not good enough for an AP reader. Just write it out and say treatments were randomly assigned. I know we try our best to find as many shortcuts in these problems, but it's not always going to work. So, random. Now, as far as independent is concerned, in fact, I didn't even need to write independent because at the end of the day, there was no sample taken for this study. We're dealing with volunteers here. So if no sample is taken, then this condition is not something we really have to check for. So, I mean, just for the sake of this problem, I'm just going to say no sample taken. If this were the AP exam, they would look at that, ignore it, and not even worry about it. So, and then of course we got to check to see if this is a normal distribution. This is of course important because most of these calculations are done using normal sampling distribution. So now, in order to check for normal distributions for a hypothesis test of 2 population proportions, you have to make sure that you calculate PC hat, okay? And it's just something you have to remember. You always have to remember which P you're going to use for the large counts condition. For example, with confidence intervals, you're using P hat. For a 1 proportion, for a 1 proportion hypothesis test, you're going to use P null. And for the sampling distribution, you're just going to use regular population proportion. So again, use my reference sheets to know which P exactly you're going to use. For 2 population proportions, we're going to use P sub C, or in other words, like P hat combined. So you calculate that by you can do the 15 plus 26, because they said it was 15 out of 500, and then for the other one was 26, and then divided by the sample sizes of both. All right, if you're not sure about that formula, go check my reference sheet. So we know that that's equal to 0.041, okay? And so now we're going to go ahead and that's our PC hat, and we're going to use that and multiply it by the sample sizes. So I'm going to do 500 times 0.041, and that gives us 20.5, and that is in fact greater than or equal to 10. And then we have 500 times I should say 1 minus 0.041, right? Which is, this ends up being 0.959. So 500 times 0.959, that gives us 479.5, and that is in fact greater than or equal to 10. And you know what? I'm going to go ahead and say for both groups. All right. Because ultimately I'm using PC for both sample sizes, but I mean both, not samples, but for both experimental groups, they have a sample size of 500 or a size of 500, not sample. All right. So that's it for the condition. So we just did our state step, we did our plan step, and then if we want to do our do step, So again, I know I told you guys, always use the calculator, list out your inputs and outputs. I just recently discovered that all they're looking for is the correct test statistic and the correct p-value. If you have those two values, you're good to go. You don't really have to do much. So let's just go ahead and tell them what function we used. So we're going to say using, on the calculator, it's a 2-prop z-test on the calculator. So using 2-prop z-test on the calculator. All right, we get z is equal to negative 1.754, and our p-value was 0.0397. And just to show you guys in case you forgot. All right, let's just go ahead and go to stat. We go to tests. It's 2-prop z-test. So it was 15 out of, not 10, but 500. 26 out of 500. We said, so I mean, this is the information for aspirin for 1. So we're saying that P1 was less than P2, the one for placebo. Calculate, and there you have it. You have your test statistic, you have your p-value. That's literally all that you need for this whole thing. So let's go ahead, and actually you'll see right here, they even gave you the combined p-hat. So if you're not even sure of how to calculate that, they gave you the p-hat for sample 1, the p-hat for sample 2, but the combined one is 0.041. I actually just discovered that as I'm recording this video. So let me move that out of the way. So that's it. You get your full credit if you just write that little bit right there. It's pretty cool. And then finally, our conclude statement, we're going to say since p is equal to 0.0397, and how does that compare with alpha of 0.05? That is smaller. So since that is smaller than alpha of 0.05, that means we reject HO. Okay, so that's always how you do. You compare your p-value with alpha. You either reject or fail to reject HO. And then from there, we can just go ahead and say we have convincing evidence for HA or we don't have convincing evidence for HA. If we reject HO, that means we do have convincing evidence for HA. So we say we have convincing evidence. And the more and more I practice these problems, the more and more I'm realizing that this conclusion part, you really are just copying and pasting what was in the problem. They say, do the data provide convincing evidence that taking a low-dose aspirin each day would reduce the chance of developing colon cancer among all people similar to the volunteers? If you can literally just say, for whenever you're concluding about your HA, we either have evidence for or do not have evidence for. It's either we have evidence for, or we have evidence that, blah, 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 or we do not have evidence that, blah, 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 blah. So honestly, just grab the problem, copy and paste it all the way down here, and you get your full credit. So I'm just going to say exactly what they said up there. So that taking low dose aspirin would reduce, so aspirin, sorry, if it looks like I'm pausing, I'm looking up. Aspirin would reduce the chance of developing colon cancer among all people. Colon cancer among... I know, this is kind of annoying, but you know what? If getting full credit in the AP exam means just copying something in front of you, I wouldn't complain. Among all people similar to the volunteers. Done. All right. That right there, this whole page right here will give you full credit for this free response question. The easiest 4 points you can get on, or the easiest full question that you can possibly get on the AP exam. All right, so make sure you look for those 4-step processes and make sure you identify what the correct method is. And once you do that, Everything will be very straightforward from there. Hopefully this video was helpful. I was hoping it would be like 10 minutes, not 15, but whatever. You can probably watch this in like 1.25 speed. So either way, good luck. And if you have any questions, of course, make sure you send me a message, and I'm going to make some more videos for other FRQs. So make sure you're on the lookout for that. See you in the next video.